Hi, I'm Robert Naini, your spray foam advisor, and the guy in the Hawaiian shirt. I wear the Hawaiian shirt as a symbol of freedom and flexibility, something that all business owners should want to achieve. And one of my goals is to help 100 spray foam business owners set up their business in a way that gets them that freedom and flexibility that they're looking for. This includes providing spray foam training, education, tips and tricks, business fundamentals, and even coaching and consulting services. Today, let's discuss some of the key considerations when applying spray foam insulation. First and foremost, the application of spray polyurethane foam insulation is temperature sensitive, and there are multiple temperature parameters that will affect the application and quality of the spray applied material. These include ambient temperature, substrate temperature, and chemical temperature. Before the actual application begins, make sure to verify that the ambient air temperature and substrate conditions meet the parameters recommended by the SPF manufacturer. The manufacturer's technical data sheet and application guidelines will provide guidance for the various temperature parameters. Additionally, most of what we discuss is high pressure SPF, which is applied with equipment that can create tremendous pressure. Once again, different formulations from different manufacturers will have varying recommended application pressures depending on the type of project and the desired outcome. And manufacturers, particularly with open cell foam, may recommend mixing, recirculation, and possibly heating of the polyol material to prepare it for application. Make sure to follow the manufacturer's application guidelines closely. When it comes time to pull the trigger and spray foam into a cavity, on a wall, or in a roof, there are several application techniques that are typically used. Let's discuss a few of the commonly used methods. Picture framing a cavity. The picture framing technique is similar to the coloring method of outlining that we all learned as children. First, you outline the edges, and then you fill in the middle. You start with the outside edges of a key area. In a cavity, that is where the studs meet the sheathing. The first step is to spray apply liquid material around the perimeter of the cavity in such a way that it adheres and seals to both the stud and a portion of the back sheathing. Once you have completed the picture framing of the cavity, now you fill in the middle of the cavity with foam. During this step, some applicators will use a Z technique, which is a side-to-side sweeping motion, and others will start at the bottom and spray straight up in the middle to fill the cavity. Fan pattern. The fan pattern technique can be very fast when mastered. It is intended to apply liquid material directly to the sheathing and back edge of the studs with a simple motion from bottom to top. A cavity can be filled with one or two passes in this manner, but the speed of the applicator's moving arm is critical to control the thickness of each pass. Feathering and fanning. The feathering and fanning technique is most commonly used with closed cell foam. For example, medium density spray foam applied to the exterior of a concrete wall or high density foam applied to a roof. The intent is to create as smooth of a finished surface as possible by feathering the continuous back and forth passes together to create a seamless monolithic application. A key rule of thumb for this type of application is to follow the wet line and overlap continuous passes by 60 to 80%. Next, thickness is a critical factor in every application of spray foam insulation because thickness has an impact on the insulation's physical properties, including R value, air barrier performance, and vapor permeance qualities. However, possibly even more important for the SPF contractor and applicator, the applied thickness of spray foam will have a direct effect on the quality of the finished product. All SPF materials are created by a series of timed chemical reactions, some of which create heat and others that are temperature dependent. You probably understand that as more liquid material is applied in a single pass, the final thickness will be greater. There is also another correlation. The more liquid material applied in a single pass, the more heat that is created by the reacting materials and the building spray foam mass. These are all relevant data points and critical to understand for the production of your materials and your production crews. So guide your production crews with these techniques help them improve their skills, and you can get better results. If you found this video helpful, then it would probably be valuable to your friends in the spray foam industry. So help us all out and send it to 3 or 4 people that you know. Additionally, if you have any questions, want info on a specific topic, or want to learn how Spray Foam Advisor might be able to help you or your business, you can email us at questions@sprayfoamadvisor.com. This has been Robert Naini, your Spray Foam Advisor, and the guy in the Hawaiian shirt. Thanks for checking this out, and catch me on some more videos.